Hey everybody, this is Larry. This is day 6 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Yeah, I mean apparently I did this like 4 times, so I probably have at least 3 videos here. But we'll try again today. It'll be fun. I don't remember I have a very bad memory. Every time I say something like that, I'm like, oh, I saw this poem 4 times. I don't really remember it, so you could trust me. Because I apparently have Alzheimer's or something. But anyway, it's just that, look, I have like 4,000 videos. There are how many poems now? 3,000 something? 3,000 poems. I'm not going to remember most of them, right? Because, why? But, we're trying to learn how to poem stuff here, not memorize all the poems here, right? So, and that's not what I'm trying to do anyway. I already don't have many brain cells, so I really try not to memorize. But yeah. Today I went for a jog, but honestly, the biggest thing I did today was slept like 12 hours. So I felt really refreshed, really full of energy. Even though I do have a race in about 10 hours. So the next day here, it's not a serious race, especially not at my current shape. But I'll try to run my best. It is a run after all. So I'll see what I can do. It's a 4-miler, which for the metric people I actually don't know what that is. 6.5 kilometers almost, so we'll see. It'll be fun. It'll be a good time. It'll be short. And tomorrow's weather seems okay. Maybe not great, but not terrible. So we'll see. Alright, let's take a look at today's problem. We have 368, largest divisible subset. The problem that I don't remember really. It's a medium anyway, so it should be fine. And given a set of distinct positive integer nums, we turn the largest subset answer such that every pair ij, answer sub I, answer sub j of elements in this subset satisfied. You have this thing and you have this thing. The multiple solutions return any of them, and n could be 1,000. Okay, so this is another subset problem. Another being referenced to yesterday when we had a subset problem. And it's 1,000 though, so you obviously should not. I mean, you could probably try if you really want to, but you should not. You should not do a 2 to the n solution, right? I think that part maybe hopefully is obvious. And the numbers get pretty big, so you can't really rely on that either. I mean, I don't know if you can, but it's just an observation, right? Before we start, let me try to think about how to do this, right? So one is that you actually need to return the solution, not just the number of the largest divisible subsets. So that's something to think about. But okay. So what does this problem mean, right? So I mean, I think that there is this talk about subset, right? And now you have these two relationships, right? Where n sub I mod n sub j is 0, 0, or n sub j mod n sub I is 0, 0. Of course, in this case, that means that here, if this is true, then that means that n sub j is going to be smaller than n sub I, right? Or equal to, I suppose, but I think they're all unique, right? In this problem, they're unique, so it's going to be smaller than, right? Or the other way around when you have this thing. And the reason, you can kind of work it out, right? Because if it's smaller, then because if the other one is smaller, then by definition, it just, won't go to 0, right? Like won't mod to 0. So, okay. But that means that in this case, you can kind of order the inputs, right, by sorting. And by sorting, it means that now you don't have to consider both relationships. You could consider only one relationship because it only goes in one direction. So that's the first thing I would do, or the first thing that I'm thinking of. And the second thing is that I need water because, sorry friends, a little dehydrated clearly from doing a quick jog, and not ready to talk a lot, but yeah. Okay. Right, so now you sort it, and now you know you have one ordering. Well, what's another one? The other thing you realize is that this problem is a transitive property, right? What do I mean by that? That means that if there is, let's just say there's a num sub I mod num sub j is 0 to 0, right? That means that, of course, num sub I is going to be bigger than num sub j. But then what does it mean? Well, it means that when you have another num sub I, right? When you have someone like this, so that, this is a num sub k, that mods num sub I is 0, 0, this means that always implies num sub k mods num sub j, right? It's 0, 0, sorry. So transitive property holds here, and what does that mean? That means that, well, that means that if, and the reason is because we have to consider every pair of subset, right? But now, here, if this is true implies that this is true, well, yeah, well, this implies, if this is true implies that this is true, and also this is true, given that there's a num sub j that's already in the subset, then it means that we don't have to care about previous num sub j, right? What I mean by that is that, for example, let's even look at example 2, right? Well, 1, 2, and 4, but that means that if we look at 4, any number that mods 4, 0, 0, let's say, in this case, maybe 8, because it's an input, but also like 16, or even 20, it doesn't have to be a power of 2. That means that every number that's smaller than 4 that we considered, it 20 also divides into them equally. But that also means that now we don't have to consider them because 4 is enough of a representative of the subset. And here we have the maximal subset, say, because we already optimized for it in a subproblem kind of way. And maybe now you see where I'm going with the subproblem talk, is that with dynamic programming. Sorry. Crazy allergies, I still wanted to rub my eyes and sneeze a lot, so my apologies if I'm being a little bit nutty. But yeah, right? So that means that if we already have the biggest answer with 4 as the last number, then we don't have to know what's before it. We just have to know that if 20 is divisible by 4, right? Then now we know what's the... So then now the problem, or the problem in the sense of the subproblem sense, is that given a number x, what is the... given a number x, what is the number... given a number x, if x is the biggest number in this subset, what is the number that... Man, my English is tough. Given number x, if x is the greatest number in the subset, what is the next number in the thing, right? And another way that you can phrase this or think about it is that it is memoryless. And as a result of, you don't have to worry about previous states in this memoryless situation. It means that you could do dynamic programming. And of course, you could write it be a bottoms up or tops down. For this one, actually, I'm going to cheat a little bit and take a peek to see what I did, and then I'll do it the other way. I could do it. I'm tempted to do it tops down, just as a heads up, but I just want to see if I did it tops down. So I did do it tops down, so I'll do it bottoms up. Yeah. And you could kind of, if you really want to see top down, you could probably watch that video anyway. So maybe today I'll try to do something a little bit different, right, with bottoms up. Yeah. No, bottoms up is not really that much different. Here we have, the thing with bottoms up though is that, and I don't know if I did this on the top down, is that you can do jump into the... Oh, okay. So I was going to talk about space optimization, but I guess you don't really need it in this. You could do the space optimization top down is what I was going to say. So okay. So I lied here. So yeah, I mean, otherwise then in that sense it is pretty much straightforward. In that, okay. So let's say you have a DP solution, right? And it is going to be, max is going to be just 1 times n, right? 1 because you always have a subset of 1 element, right? That's that's it. And of course, I almost forgot. We talked about it. We should sort it. And actually, the input is sorted, so I would have gotten the wrong answer if I had forgotten about it, because if I assumed that it is sorted, right? And then the other thing that you could do is just call the previous, right? And here, DP maybe, I just call everything DP for dynamic programming, but you could even call it like maybe BES or whatever. You can name it a little bit more descriptive. But previous, and I always name it previous because I think about it as a graph, but you don't have to. But it is just basically remember the edge that leads to the best solution, right? So previous sub I is the best previous edge that goes to index I. Something like that. I mean, maybe the phrasing is a little bit not perfect, but yeah, right? And that's really it, right? So now you start with, yeah, it's already sorted, so we could start with the second number, right? So, which is 1, because, yeah, the first number is my base case. And then now you could do for j in range from 0 to I, not including I, then now if num sub j mod, or the other way around, sorry, num sub I mod num sub j is equal to 0, because keep in mind that these are all smaller numbers, right? If this is true, then now we check, right? So if dp sub j plus 1, 1 being, you add one more number to the previous best subset of dp sub j, is greater than, if it's greater than dp sub I, then dp sub I is equal to dpj plus 1, and then previous sub I is equal to j, right? And that's it. That's all you have to do for this dynamic programming. Yeah. Pretty straightforward. Of course, you can return dp, technically you would return max of dp, not just the last element for this one. If all you wanted was the number, which of course is not the case, we want the actual number, right? And which is why we have this previous. So now first we have to find out what the max of dp is. And of course any is fine, right? So yeah, so we can maybe do like max dp, so this is the best, right? And then now we just go for I in range of n, or n minus 1, sorry, going down. If dp sub I is equal to best, then we kick it off, and then we just return, right? Otherwise we return, I think this always returns anyway, because by definition that'll return the first element, but I don't know, maybe we just else assert force, then maybe that's a little bit cleaner in terms of expectation, maybe, but I don't know. For context it could vary, right? We just have to prove that correct a little bit. But otherwise, if this is the best, and we will just return answer for some answer, right? And then now we know that the last element in answer is going to be num sub I, if I type it correctly, right? Then now we go, okay, well, what's the previous node, right? So current, we're gonna have say it is at index I, and then while previous of current is not none, then current is equal to previous current, right? So then we basically path reconstruction through the edge that we go through, right? And of course every path we discover something, so we want to append num sub I, right? Or num sub current, sorry. I think we did it the other way, so maybe we start at 0, and then now this means that what happens after this while loop? That means that previous current is none, but that means that this is the last node, right? So that means that we will also, all I mean is that we can also just append it, and that should be good. Oh, well, now that, because we did it backwards, and the reason why I did append is because it's cheaper to do append than prepend in, but we have it backwards, so we have to reverse it, and that's it. Hopefully, yeah. Like, you don't have, it doesn't have, there are multiple answers, so you don't have to optimize for anything else other than that it is correct and max mode. So let's give it a quick submit, and there you go. Yeah, easy peasy, right? And of course, some days I do forget to mention this beforehand, but yeah, I think about the complexity. I knew that it was going to be n squared, and n equals to 1,000, so we are good, and that's why I didn't really, I mean, I didn't talk about it. I should have. It's just that it went from my mind very quickly, and I just forgot to talk about it. But yeah, I knew that doing this way, just going back, and yeah. So this is n squared, and the path construction is over n. So the reason why this works, of course, is I already talked about this, so it's not like I'm dropping at the end, but I want to bring it again just for emphasis, is that there are two things, right? One is the sorting. The sorting allows us to just have this in one dimension, but the biggest thing is that this the transitive property kind of thing, right? It allows you to look at just one representative node, which is how this DP gets connected, because now each node contains the biggest subset with it as the biggest number, right? So then as you just build one on top, and that's basically the idea. But yeah, that is all I have for this one. Allergies. Let me know what you think. Yeah. I'm gonna delete an empty line here just because. So then maybe a split. Okay, now you can see most of it. But yeah, yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.